All right, guys, here is our fill in the unit circle. And so what I want to talk about first is the basics of the unit circle. So on the unit circle, there are two increments. There are 30, 60, 90 increments, and there are 45, 45, 90 increments. So first thing we're going to do is talk about these ones right here, which are the degrees. So we start off right here. Here's my x-axis, right? Here's my y-axis. I'm going to go ahead and highlight those. I don't know if I have a ruler. Let me look. I don't think I do. And so I will use this straight edge right here so that we can have our x and y-axis clearly labeled. So here's my y-axis, and maybe I'll do my x-axis in a different color. Here's my x-axis in a different color. And so here is my x-axis. Okay. So there are my x and y-axis. And we start on the x and y-axis at 0 degrees. And then if we rotate a quarter the way there, we'll be at 90 degrees, and then 180 degrees, and then we'll be at 270 degrees, and then we'll be right back to 360 degrees. I actually don't like this right here, so I'm going to fix it. So 270 degrees. All right. Now, halfway in between, which I know it's kind of hard to tell for some of us are very visual. Halfway in between is right here. I'm going to highlight that or draw in that with a pink line. So right here, halfway in between would be 45 degrees. So this is a 45-degree angle from here to here. Now we need to go back to our 45, 45, 90 special right triangles. So if you don't remember a 45, 45, 90 triangle, I'm going to really quickly recall, right? Let me make sure you can see the bottom of my page. Yes, you can. Okay. Recall 45, 45, 90 special right triangles. Your ratio is 1, 1, root 2. Okay. So this, though, is called a unit circle. On the unit circle, the radius of the circle from here to here, or from here to here, or here to here, or here to here, is only 1 unit. So this length from here to here is 1 unit. So what I'm going to do is I'm going to go ahead and I'm going to drop a altitude from the from the radius of the circle straight down to the x-axis. And what that does is it creates a right triangle where this angle is 45 degrees, this angle is 90 degrees, which means this angle must also be 45 degrees. And what I'm going to do is I'm going to create a ratio to find this missing side length, which is our x value. And I'm going to create a ratio to find this missing side length, which is our y value. And to do that, I'm going to draw my special right triangle, reference triangle. So I have x is to 1, x is to 1 as the hypotenuse 1 is to the hypotenuse here, which is square root 2. And then I can go ahead and solve for x. Well, x is already solved for. X equals, now we are not allowed to leave a radical in the denominator, so I'm going to rationalize by multiplying both the top and bottom by square root 2. And that gives me square root 2 over square root 2 times square root 2 is square root 4, and the square root of 4 is 2. So that tells me that the length of x right here, which is also this distance, is square root 2 over 2. Now, similarly, I could, if I wanted to, redo this process for y, but in a 45, 45, 90, the legs are congruent. And so that tells me that y is equal to x, which is equal to square root 2 over 2. All right, so we're just doing 45, 45, 90s. So over here, the next increment of 45 would be right here at 90 degrees. And the next increment of 45 degrees would be, if I add 45 to 90, 45 plus 90 is 135. So that means that this one goes to this one, right? This middle one right here is 135 degrees. And what will happen is if I reflect this triangle over, so I'm going to do that. I've got another 45-degree angle. Always, I make my reference back to the x-axis, draw in my angle. That means that this angle from here to 180 is a 45-degree angle, which means that here's my right triangle. Let me sketch it in, right in pink. There's my hypotenuse. My hypotenuse is always 1 on the unit circle. That means that this value, x, and this value, y, right, they're the same triangle, they're just reflected. So what happens is they're the same lengths, square root 2 over 2, and square root 2 over 2. However, in this quadrant, the second quadrant, our x values are always negative. And so my x value would be negative square root 2 over 2. And so similarly, we can do that with every single one of these 45-degree increments. So here I am, another 45 degrees. I will drop a altitude this time up to the x-axis. And this angle will be 45 degrees, which means that this angle is also 45 degrees. Again, the hypotenuse is always 1. So this is just a reflection of this triangle. So my values, my lengths of my legs, x and y, will still be square root 2 over 2 and square root 2 over 2. But what's different now is that not only is x negative, so I'll put a negative on x, but also y is negative, so I'll put a negative on y. And then finally, my last one, which is right here. Oh, let's look at how many degrees this would be. 180 plus 45 degrees would be 225 degrees. And then if I add 45 again, I'll be at 270. And if I add 45 again, I'll be right here at 315 degrees. So here's another 45-degree angle. So again, from the center out, here's my radius, it's 1. I'm going to drop an altitude up to the x-axis, and that means that this is a 45-degree angle from here to here. And here's my y, and here's my x. And that means that this triangle is just a reflection of this one. So the lengths of the legs are still square root 2 over 2 and root 2 over 2. This time my x values are positive, but my y values are negative. All right, so now we've talked about 45 degree angles. We're going to talk about this coordinate right here, this coordinate right here, this coordinate right here, and this one right here. So we said it's a unit circle. That means that the radius from here to here is 1 unit. That means that this point would be the point 1, 0. So that's 1, 0. Going straight upward, right, on the y-axis, this point would be up 1, which would be the point 0, 1. And similarly, going to the left 1 unit, we'd be at -1, 0. And then going down 1 unit, we'd be at 0, -1. Okay, the last thing we need to do is talk about radians. Okay, so we said to convert degrees to radians, you take your degrees and you multiply by pi over 180. So if, for example, I'm here at 0 degrees and I multiply by pi over 180, I'll be at 0 pi. If I'm right here at 45 degrees, so 45 degrees times pi over 180. I'm just going to triple check that you guys can see my writing, barely. And then we look for something that will go into both 45 and 180, which is actually 4. So 45 goes into itself once and into 180 4 times. So this is pi over 4. So in radians, this is going to be pi over 4 right here. Pi, whoops, wrong one, right here. Pi over 4. So I'll erase this guy. Okay, 90 degrees, we'll do the same thing. 90 degrees times pi over 180. 40 will go into both. 90 goes into both. 90 goes in there once and 90 goes in there twice. So this is pi over 2. So that's pi over 2. Now you can keep doing this, right? I'll do one more. 135 over 1 times pi over 180. 45 goes in there 3 times. 45 goes in there 4 times. So that's 3 pi over 4. So this is 3 pi over 4. And then I'll do it again and again and again. And what happens is that this ends up being 2 pi. And then what I notice is there's a little trick. What we're doing, or sorry, not 2 pi, it ends up being pi, excuse me. Right, 180 times pi over 180 is pi. And then what ends up happening is I notice that from here to here, I've divided 1, 2, 3, 4 increments, right? So I've divided pi into 4 increments. That means that each time I'm counting by 1/4. So this is 1/4 pi, which is the same as 1 pi over 4. This is 2/4, which is the same as a half, 3/4, and then 4/4, which is 1. And once you see that trick, you don't have to keep converting. So this was 4/4. This will be 5/4, which is 5/4, and I'll put pi in the numerator. 6/4, but 6/4 reduces to 3/2, or 3 over 2. 7/4, and then 8/4, but 8 over 4 is 2, and then we put pi in the numerator. All right, guys, now we're going to go on to 30, 60, 90s. And I actually thought ahead and printed out a second unit circle. And so again, I'm going to highlight my X and Y axis. Let me see if I can just do it without a ruler. I think I can manage. So there's my X axis. And there's my Y axis. And this time we're going to be ignoring the pink ones that I was putting in before, and we're going to be using increments of 30 degrees. So again, with our degrees, this is 0 degrees, this is 90 degrees, this would be 180 degrees, 270 degrees, and then 360 degrees. Now, this is my 30, 30, 30, 30, 30, 30, counting by 30s each time. So from 0 to 30 is 30. If I go 30 degrees more, right, skipping over this 45, that would be 60. 30 more degrees would be 90. 30 more would be 120, 150, 180, 210, 240, 270, 300, 330, and 360. All right, so using this length right here, right, we know that the length of the unit circle, again, I'm going to go back to that word unit circle. They're telling you the hypotenuse is 1 unit. 1 unit. And I'm going to drop a altitude straight down. To the x-axis, and that will make a 90-degree angle. Now I know that this angle was 30 degrees and this angle is 90. That means that this one must be a 60. So we're going to look back at our 30, 60, 90 reference triangle. So if you'll recall, in a 30, 60, 90, the relationship between the legs, the short leg is 1, the hypotenuse is twice as large, and the long leg is √3 times as large, so 1√3. Now, if I want to find these missing lengths, this is my x-axis, right? So x. This is my y value, right? I'm going up and down, which is y. If I want to know my x and y values, I can create a proportion where I say x is to square root 3, x is to √3 as 1 is to 2. If I cross multiply, I get 2x equals square root 3, and then divide by 2. X is √3 over 2. Now this time I do have to do the same thing to find y. So I'm going to create a proportion. Y is to 1 as 1 is to 2. I don't need to cross multiply. Y is already solved for. Y is 1/2. All right, so what I'm going to do is I'm going to see that there's the same triangle over here. So this triangle is a reflection of this triangle. Here's my x and here's my y. So what happens is that these lengths are the same and these lengths are the same. So my x is still √3 over 2 and my y is still 1/2. The only difference is x is negative here, and so I'll put a negative on that. I can reflect this triangle downward to right here. Again, this is my 30, right, degree angle. So this will be my 30-degree angle. And I notice that this x value and this y value have to be the same as this x and y value, which is √3 over 2 and 1/2. So √3 over 2 and 1/2. The difference is here that y is negative and x is negative. So these will both have a negative. I can reflect this triangle down here. And what I'll have is the same triangle. Right, this will be a 30-degree angle. And so my values will still be √3 over 2 and 1/2. But the difference will be here, x is positive, but y is negative. And so I'll put a negative on the y value. All right, if I go to this increment right here, if I drop an altitude straight down to the x-axis. Now this is my x value, and this is my y value. And what you should notice is it's still this is my 60-degree angle now, right from there to there. And now my 30 is up here. So all I've done is I've taken this triangle, the pink one, and I've rotated it and flipped it so that it's sitting on the shortest leg. So before, the shortest leg we noticed was right here, which was our y value, which is 1/2. Well, that means my shortest leg now, right, it's a similar triangle, it's the same value. The only difference is that my x value is now what my y value was. And so now my x is 1/2, because this is my short leg and this was my short leg. And now my long leg, my y value, is what my x value was, which is √3/2. And so similarly, I can reflect this purple triangle across to right here, right, drop straight down. These values will still be the same values, right? My x value is still this same x value, which was 1/2. My y value right here is still this same y value, which is √3/2. The difference is x is negative here, so I'll put a negative. I can reflect this triangle downward. And now this angle, or sorry, this value is y, and this value is still x. So still the same two values, 1/2 and √3/2. The difference here is that both x and y are negative. So I'll put a negative on each one. And I can reflect this triangle down here, where this is now my y value. And so I'll have these same two values, 1/2 and √3/2. But in this quadrant, x is positive, but y is negative. So I'll put a negative only on the y value. And now let's talk about radians. I'm not going to show converting degrees to radians again. I just did it. But if I were to convert this angle right here, this 30-degree angle, into radians, I would get pi/6. I would have 30 degrees times pi/180. 30 would go in there once and in there 6 times. That's pi/6. If I do it again with 60 degrees, it's twice as big. I'll have pi/3. This won't change. This is still pi/2. Here I get the same value as before, pi. And now let's see if we can figure out what am I counting by to get from 0 pi to 1 pi. And again, I'm ignoring these lines in between. So I have 1, 2, 3, 4, 5, 6 movements. So that I'm counting by sixes or sixths. So this is 1/6, 2/6, which reduces, 3/6, which is 1/2, 4/6. 4/6 is the same as 2/3. So this is 2/3 pi. And then 4/6, 5/6, and 6/6, which is 1. Then this would be 7/6. We'll put our pi in the numerator. 8/6, but that reduces. 8/6 is the same as 4/3. 9/6, which is the same as 3 pi/2. 9/6 and 3/2. 10/6, which reduces. 10/6 is the same as 5/3. 11/6 and 12/6, which is 2 pi. Oh, this was 0 pi. All right, so let's combine all of that together onto one complete circle. So we're going to combine all of this information with all of this information. So I'd like you to go ahead, and if you haven't already, print out a unit circle. If you can't print one out, then carefully, right, sketch a unit circle. I'm going to go ahead and fill in. And now we're going to do something kind of cool. what we're going to do is, it's called a unit circle race, right? So a unit circle race is where you try to beat me and go faster than I can on the unit circle by filling in all of these values. All right, so I'm going to go ahead and fill in my values. These are root 2 over 2 and root 2 over 2, root 2 over 2, root 2 over 2. This guy's negative. They're both negative. Put in my zeros and ones. Let me do that in a different color. What else am I missing? Oh, I'm missing some degrees. I'll put those in. So I'm missing 45s, 45, 135, 225, 315. And my radians, this is pi over 4. This is 3 pi over 4. This is 5 pi over 4. 7 pi over 4. Anything else that I'm missing? Not on the circle. Okay. All right. Now that was all my unit circle notes. I haven't filled in the positive negative yet because I'm actually going to leave that for the next set of notes. So from this set of notes, what you should be able to do, okay, I'm going to get rid of this guy so that there's no writing over here. What you should be able to do is fill in your unit circle. So the homework tonight, everybody's paying attention, right? The homework. I'm going to flip this over. I want you to recreate or print a blank unit circle. So if you need to recreate it, you're going to take a ruler, you're going to draw an x-axis, you're going to draw a y-axis, and then you can use any round object, right, to make a circle. And then I want you to divide your unit circle into the same increments. So you should have like roughly one right in the middle for each one, and then one slightly above and below, slightly above and below, and so on. If you have a printer and you can print one out, that's even better. And then I want you to fill in your blank unit circle. Now, I put a copy, so recreate or print a blank unit circle, fill it in completely. So you should have degrees, radians. You should also have your X and Y coordinates. And watch your signs. After you've filled in your unit circle, the next set of notes will be using the unit circle. Now, the reason I'm redoing this, for those of you who understood this lesson, wonderful. But I got a lot of comments that people were very lost, so you need to understand the unit circle before you can use it. All right, so, and what I was saying about printing a blank unit circle, I actually gave you guys on the last classwork a blank unit circle to use. And I gave you a completed unit circle to use. So what you're not going to do, I guess I'll put it down here. Do not simply copy a unit circle. What I want you to try to do is to think about, if I'm right here, how many degrees is that? Well, if this is 0 and this is 90, this must be 45 degrees. if I'm right here, how many degrees is that? Well, if this is 90 and this is 45 from here to here, then this is 45 more. So I'll be 90 plus 45. Well, that's 135, and so on. And then I'll be at 180, and then I'll be at, and then I'll be at, and so on and so forth. I want you guys to think about it as you fill in your unit circle. And then I believe after, so this is part 1 of the homework, right? Part 2 of the homework will be a practice worksheet. After you have filled in your unit circle though, please make sure, so the last thing is check it. If you have something filled in incorrectly, you're going to be using it incorrectly. All right, guys, that's it. Have a good evening.